Hello, in this video we will look into tuning and calibration for multi-axis steering. When the machine is first started, it will boot up into calibration mode. For multi-axis, the spool and WASP calibration must be done differently than in the traditional firmware. In the traditional firmware, WASP calibration is done by moving the wheels to the left, right, and neutral positions with the steering wheel and capturing the corresponding values. In multi-axis, we cannot use the steering wheel to move the rear wheels while in WASP calibration mode, so this must be done using the direct output control mode. Enter into the direct output control mode using the Go to Direct Output Control Mode button. Then request a spool position outside the deadband, for example, plus or minus 150, and wait for the wheels to hit the end stop. Once the wheels are at the end stop, go to the WASP calibration page and press Go to WASP calibration mode. Then press Capture L or R to capture the values for the left or right side. This should be repeated for both sides. The center position is found by entering direct output control mode and requesting a spool position just outside the deadband, and then requesting a neutral spool position when the wheels are in neutral. Then go to WASP calibration mode and capture the neutral position. After capturing all of the values in the WASP calibration page, press Accept and Save. It is important to only press the Accept and Save button once all the values are captured. In the standard firmware, the spool can be calibrated by entering spool calibration mode and turning the steering wheel to engage the auto spool calibration. However, often this will not work for multi-axis. In this case, the spool can be calibrated manually using the direct output, status messages, and valve calibration data pages. To find the deadband edges, the spool position should be decreased using the direct output control mode until the wheels will no longer move at a constant velocity. Once the wheels stop moving smoothly, raise this value slightly so that the wheels will just move at a constant velocity. This is your closed loop deadband edge and should be entered into the valve calibration data page. The open loop deadband edge is the spool position when there is no flow to the wheels. This is entered as the open loop deadband edge offset and can be decreased from 25 but should not be increased. Once the machine is calibrated, it is time to get the machine operational. The process to do this will depend on the steering input devices being used, as well as if any other steering solutions are desired. When troubleshooting, the diagnostic pages in Service Tool can be very helpful, mainly the status messages and error history pages. The status message page can be used to view data, such as what state the machine is in, spool position, and analog sensor data, as well as other information. The buttons on the side of the screen can be used to turn off or set the rate at which status messages are being received. The error history page can be used to find and diagnose errors that occur. Clicking on the error record button will cause an error code to appear, which can be identified using the multi-axis technical information. Another helpful document is the multi-axis communication protocol, which can be used to break down the raw CAN messages from the machine. The state machine diagram shows what parameters are used to control the transition to and from the different multi-axis states. For the slave axis to change from pre-operational to operational, the error between the wheel angle and wheel angle set point must be less than the value set by P3910. This is used to avoid surprise movement, especially during startup. To go from operational to on-road, the vehicle speed must be greater than the value set by P3908 plus half of the value set by P3907. Once in the on-road state, if the vehicle speed drops below the value set by P3908 minus half of the value set by P3907, the slave axis will transition to pre-operational. The hysteresis band should be used to avoid state bouncing when the vehicle speed is hovering around the VSP trigger mean. When transitioning from on-road to the on-road lock state, a timer of the value set by P3094 It started to set the maximum time allowed for the slave axis to steer to straight. The multi-axis control algorithm then moves the slave axis cylinder to a straight position. When the slave axis angle is below the straight range, set by P3909, the state will change to on-road locked. The slave axis can also transition to and from on-road state based on the state of the road switch. With all the profiles at your disposal in the in-axis config page, you will be able to unleash the full maneuverability of your machine while operating safely and smoothly. That is all for this video. Thank you for watching.